Alright, these are the 5 notes. We're going to be talking about solving multi-step inequalities. Solving multi-step inequalities is exactly like solving multi-step equations, where you work backwards from the order of operations and you take care of your addition and subtraction first, and then your multiplication and division second. The only thing you have to keep in mind is when you're dealing with inequalities, if you multiply or divide by a negative number, the inequality sign has to flip. Other than that, it's exact same as solving multi-step equations. So, just like I said before, we can solve multi-step inequalities by undoing the operations, the same way we did with multi-step equations in section 2.3. If you get confused, you should pull out your 2.3 notes. That will help. You have to remember that when you multiply or divide by a negative number, you have to flip the inequality sign. Okay, so here's an example. Negative 11y minus 13 is greater than 42. If this had said equals 42, we would just start by adding 13. Same thing happens here. So we're going to add 13 to both sides, and we get negative 11y is greater than, because these cancel, 55. Okay? Last step, divide by a negative 11 to get the y by itself. Now, I'm dividing by a negative, so this sign has to flip. So I'm left with y is less than negative 5. That's my solution. The last thing I want you to do is write it in set builder notation. So we have y such that y is less than negative 5. And remember, that means that y can equal any number, but we are only concerned with y is less than negative 5. Okay, I want you to try the next two on your own. I'm going to keep going, so you need to pause the video and then come back when you're ready to keep following along. Okay, so this example reads 23 is greater than or equal to 10 minus 2w. First thing I want to do, get rid of this 10. I want the two w's by themselves. It's positive, so I'm going to subtract it from both sides. And I get 13 is greater than or equal to negative 2w. It stays negative because in the original problem, it's being subtracted. These will cancel, so we're left with that negative 2w. Okay, I want to get the w by itself. It's being multiplied by negative 2. So to undo that, divide both sides by negative 2. I get a fraction or a decimal. I'm going to leave it in fraction form, and I get negative 13 over 2 is less than or equal to w. The reason it goes from greater than or equal to less than or equal to is because I divided by a negative 2. So I want to write this in set builder notation, but remember from the first section in chapter 5, we started learning that set builder notation asks for us to give the variable first. Well, in this case, the number comes first and the variable comes second. So in order to write it in set builder notation, we have to flip it around and put w first, which means my inequality sign will flip because we see that it opens to the w here. It needs to open to the w here. Negative 13 over 2. Okay, now it looks like how I want it, and I can write it in set builder notation. W can equal anything, but I'm only concerned with w's that are greater than or equal to negative 13 halves. Okay? That's our answer. Now, let's go down here and deal with this one. This reads, 43 is greater than negative 4y plus 11. I want to get the negative 4y alone. Right now I'm adding 11, so to undo that I will subtract 11, and I will get 32 is greater than negative 4y. The last thing I want to do is get the y by itself, so I'm going to divide each side by a negative 4. On the left hand side I get negative 8 is less than, it flips because I divided by a negative, y. Okay? Again, our variable comes second, and to write it in set builder notation, I want it to come first. So I'm going to flip it around. I'm going to say y is greater than, the inequality sign opens to the y, so it has to open to the y over here, negative 8. So I'm talking about y's such that y is greater than negative 8. And there's our solution. Turn to the next page. Here's an example of a word problem that you might see when we're talking about multi-step inequalities. It tells us, write and solve an inequality to find the sales Mrs. Jones needs if she earns a salary of $2,000, so no matter what, she earns $2,000, plus a 10% commission on her sales. So for every sale that she makes, she gets 10% of that commission. Her goal is to make $4,000 per month. What sales does she need to meet her goal? So we know that she's making $2,000 no matter what. Plus, she makes 10% of her sales. So we're going to write 10% as 0.10, because remember 10% as a decimal is 0.10. Now, of every sale she makes, I'm going to let X be the number of sales. Okay? So 10% of each of those sales. And she wants to make at least $4,000. So this number, her salary plus her commission, has to be bigger than or equal to that $4,000. Okay? This is the amount of money she makes, and she wants to make at least, so more than or equal to $4,000. So we wrote our inequality. Now we just have to solve it. I want to get that 0.10x by itself. Right now we're adding 2,000 to it, and that 2,000 is positive. So I'm going to subtract 2,000 from both sides. Okay? So on the left-hand side, I'm left with a positive 0.0 or 0.10x. It's still bigger than or equal to, now it becomes $2,000. Okay? I want to get x alone. We're trying to find out how many sales she needs to make. So we're going to divide by 0.10. Okay, on the left-hand side we're left with x. Our inequality sign stays the same because we divided by a positive, and we get 20,000. Okay, so if we were to interpret this, because great, x is greater than or equal to 20,000, but what does that mean for Mrs. Jones? It means Mrs. Jones needs to sell at least, because remember, greater than or equal to means at least, $20,000 of merchandise. Okay? Turn to the next page. Here's another example of a word problem to try. I'm going to let you guys try this one on your own, so you need to pause the video, come back to it when you're ready. I'm going to keep going, so you do need to pause the video. Okay, the print shop advertises a special to print 400 flyers for less than the competition. So the number of flyers that they're making is 400. The price includes a $3.50 setup fee, so no matter how many you make, you have to still pay at least $3.50. And the competition charges $35.50. What does the print shop charge for each of the flyers? So we need to know the charge per flyer, because we know how many they're making, we know how much they want to be less than, we want to be smaller than the competition, and we know that they have an initial setup fee of $3.50. So let's start with making our inequality. We know no matter how many flyers we make, we're going to get charged $3.50. Then they're saying we want to make 400 flyers because that's their advertisement. Now for each of those 400 flyers, they're going to charge us, and we don't know what that charge is. That's what we're looking for, and we defined it as C. Now they want to pay less than the competition, so we want to pay less than $35.50. We're not including an equal to sign so it's not less than or equal to, because they're telling us right now it's less than. They're not going to pay $35.50. They're going to pay at most $35.49. So we wrote our inequality. Now we can start solving. I want to get the 400C alone, so I'm going to subtract 350. Okay. On the left-hand side, I'm left with a positive 400C. Inequality sign stays the same, and I'm left with $32 even. Now, I just have to divide by my 400. It's a positive number, so my inequality sign stays the same, and I get 0.08. So, if I were to read that in dollars, I would see that it is 8 cents a copy. We're talking about a real life situation, so this would be something that you would want to interpret the answer. So the print shop will charge less than 8 cents for each flyer. Okay? Turn to the next page. We've been doing a lot of interpreting sentences back into the algebraic form and then solving. That's what we're going to do here. We've had it practice with us in sections 5.1 and 5.2. This is just going to teach us how to do it with multi-step inequalities. So, first thing you have to do is define a variable, then write an inequality, and then solve the problem. You should also put and write solution in set builder notation. Okay, so it starts with letter A. 5 minus 6 times a number is more than 4 times the number plus 45. So the thing we don't know is the number. I'm going to let it be n. That defines my variable. Then we just start writing things down. We know it's 5 minus 6 times our number. It tells us it's more than, it doesn't say equal to, so just more than. 4 times that same number, so 4 times n, plus 45. Okay? We wrote our inequality, we defined a variable, we wrote our inequality, now we have to solve it. So, do you remember in section, I think it was 5.2, we talked about how variables can be on both sides of the inequality. We can still solve that, but we want to move them to one side. Now, it would make sense to move the 6 because we would end up adding it, whereas if I subtract the 4n, I'm going to get a negative. Since we know how to deal with those negative numbers now, I'm going to let you choose what you want to do. I'm going to add the 6n. I'm going to say plus 6n to both sides. This gets my variable on the same side. I get 5, this cancels, is greater than 10n plus 45. Now I want to get the variables alone, so I want to get the 10n alone. So let's subtract 45 from both sides. So I get negative 40 is greater than 10n. Now I want to get the n alone. I'm going to divide each side by 10. And negative 40 divided by 10 is negative 4. Is greater than, it stays the same because it's a positive 10 that we're dividing by, n. So this is my solution, but I want to write it in set builder notation. And in order to do that, I have to flip it around so that the variable comes first. So I get n is less than negative 4. Set builder notation looks like n such that n is less than negative 4. Alright, I want you to go ahead and do B by yourself, and you should pause the video because I'm going to keep going and then come back to it when you're ready. Okay, our sentence reads 2 more than half a number is greater than 27. I'm going to let n be my number again. So I have defined my variable. 2 more than, so that means 2 plus half a number, so 1/2 of our number is greater than 27. So I want to get that half n alone. I'm going to get rid of that 2 out front. It's positive, so I'm going to subtract it. I'm left with half n is greater than 25. Now, I'm multiplying by 1/2. In order to undo that multiplication, I have to divide by 1/2. Remember that dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm going to end up multiplying this by 2 over 1. These will cancel. I'm left with n greater than 50 over 1, which is just 50, so I'm going to leave it like that. Now, the inequality sign stays the same because I multiplied by a positive 2. So this is my solution. To write it in set builder notation, it's n such that n is greater than 50. Okay? All right, turn to the next page. Sometimes you're going to start seeing things that have grouping or parentheses with the number outside, and we know that we should work back from order of operations, but sometimes if we don't deal with our distributive property first, we'll get weird fractions, and that's more difficult to deal with than just doing our distributive property first. So when you see grouping in an inequality, and then start solving. So I'm going to distribute that 4. I get 12t minus 20 plus 7. So 4 times 3t gives me the 12t. 4 times a negative 5 gives me the minus 20 plus 7. It's greater than or equal to 8t plus 3. Okay, first thing I want to do is I want to simplify that left-hand side. I have a couple of like terms that I can. So I can combine that negative 20 and that 7 because they have the same variable, which they don't have a variable. And so the 12t stays the same. If I'm subtracting 20 but then adding 17 back in, I'm actually just subtracting 13, greater than or equal to 8t plus 3. Now I want to get all the variables on one side, and since they're both positive, it makes sense to bring the smaller one to the other side. So I'm going to bring that 8t over. It's positive, so I'm going to subtract it. So I'm left with 4t minus 13 is greater than or equal to positive 3. All right, I want to get the 4t alone, so I'm going to add 13. 4t is greater than or equal to 16. I want to get the t alone, so I'm going to divide by a positive 4. T is greater than or equal to 4. It stays the same because I'm dividing by a positive number. Okay, set builder notation would look like this. T such that t is greater than or equal to 4. Okay, so all of this solving is the exact same as what we've been doing this section. You just have to remember that at the very first step, you have to use a distributive property to get rid of your parentheses and then simplify. Okay, I want you to go ahead and try examples A and B on your own. Before you get started, I want you to go down and look at letter B. There are parentheses on both sides of the inequality. You deal with it the exact same way. You just have to distribute on both sides. I'm going to keep going, so you should pause the video and come back when you're ready. Okay, so in the first one, it gives us 6 times the quantity 5z minus 3 is less than or equal to 36z. Okay, we've been talking about the distributive property, so we're going to distribute that 6 to both pieces. I get 30z minus 18 less than or equal to 36z. Okay, I want to get all of the z's on the same side, so I'm going to move the 30z because they're both positive, and I want to move the smaller one. It's positive, so I'm subtracting it. Cancels over here. I'm left with negative 18 is less than or equal to 6z. Trying to get the z by itself, so I'm going to divide each side by a positive 6. I get negative 3 is less than or equal to z. Set builder notation means I need to have the z come first, so I just flip everything around. Z is greater than or equal to negative 3. Now I can write it z such that z is greater than or equal to -3. All right, let's look at letter B. I'm going to distribute everything first, including that -3 on the right-hand side. So I get 2h plus 12 is greater than -24 plus 3h. First thing I want to do is get all of the variables on one side. Right now I have a positive 2h and a positive 3h, so I'm going to move the smaller one. I'm going to subtract 2h from both sides. I'm left with a positive 12 is greater than -24 plus 1h. Okay? I want to get the 1h alone, so I'm going to add 24. I'm adding 24 because right now it's negative. So I get 36 is greater than 1h. And we know that 1h is the same thing as just h. So now it's solved. I'm going to write it in set builder notation though, so I need to rewrite this so that h comes first. H is less than 36. So I get h such that h is less than 36. Alright, turn the page. Now, we dealt with something called an identity when we were talking about equations, and that's when you get something like 0 equals 0 or 100 equals 100, because no matter what happens, 100 will always equal 100, 0 will always equal a 0. And so that means that all real numbers make that equation true. So when I'm dealing with an inequality, that same thing can happen. When we go to write that in set builder notation, you'll write it as x can equal anything, and we are worried about x being a real number. That's the only thing that matters. So it's saying x can equal all real numbers. Let's try this one. So I'm going to distribute the 3 on the left-hand side and distribute the 6 on the right-hand side. And I'm going to get 12m plus 18 is less than or equal to 42 plus 12m minus 24. So I want to simplify. The left-hand side is fine. I have 12m plus 18. Less than or equal to. Now I can combine the positive 42 and the negative 24 since they're like terms. I'm going to put the 12m out front. And since this is positive, I will just subtract the 24 and it gives me 18. Now look, we're setting ourselves up for an identity here because we have 12m plus 18 is less than or equal to 12m plus 18. If we were only worried about that equal to sign, would this always be true? Yes, absolutely. 12m plus 18 is the exact same thing as 12m plus 18, so they're going to equal each other. So, this is always true, no matter what m equals. So, when we write our set builder notation, we write it as x such that x is a real number. All that means is that x can equal anything. Okay, turn to the next page. So just like they can always equal it themselves, we can also get things like x is or 0 is greater than 4. That's never true. So then you get an empty set or no solution. When we write empty set, you write a 0 with a slash through it. That means that there's no elements in that set. Let's try an example. We're going to distribute the 5 on the left and distribute the 4 on the right. So I get 9t minus 5t plus 25. It becomes plus because I'm taking a negative 5 times a negative 5 makes it positive 25. Less than or equal to 4t minus 12. Okay, we're going to simplify. 9t and 5t are like terms, so we can combine them. I have a positive 9t minus 5t gives me a positive 4t plus 25 is less than or equal to 4t minus 12. We're going to keep going with this one, but we can already see that we have 4 t's plus and minus different numbers. So it's never going to work out for us, but we're going to just keep going to see that. I want to get rid of my variable terms. So I'm going to subtract the 4t from both sides. So I get 25 is less than or equal to negative 12. Let's deal with the less than first. Can 25 ever be less than a negative 12? No. So that part will never be true. Now let's deal with the equal to. Can 25 ever equal negative 12? No. So neither case works here. We can't ever have 25 less than or equal to negative 12. So no solution. This can't happen. When we write it in set builder notation, you just write it like this. Empty set. Doesn't work. Okay? That's the end of the notes. So I want you to take a look at the homework. Remember that you need to finish the homework from section 5.2. If you have any questions, let me know. Otherwise, I'll see you in class tomorrow, and we will go over any questions and examples that you would like.